today we are going to start Unit 1. So really Unit 1 is going to, some of it's going to repeat from Chapter P, but most of it is going to be sort of some new material. The main thing is pre-calculus is we're really, for the beginning of the first semester, we're going over functions. Well, we need to be able to do everything with functions and know what functions are. So to start, the the name of the book is Pre-Calculus Graphical, Numerical, Algebraic. So first thing we should know is, what does that mean? Numeric, algebraic, graphical. So when we look, if it moves, it's not responding. We'll see what happens. Now it is, but it skipped. Okay, so numerical model, the model in which numbers are analyzed to gain insight into phenomena. Well, really, it's you just looking at numbers that have some meaning data. So, I give you something that shows the year, the minimum wage, and purchase power. You can make some generalizations. As the years went on, minimum wage went up. As the years went on, purchase power, well, it went up, but then it started to go down. So, you can just look at data and make some generalizations. I just want you to know, numerical is data. Algebraic, you have an equation or a formula that relates variable quantities associated with what is being studied. It can be used to generate values of unknown quantities. If you have an equation, y equals 2x plus 7, you can tell me that if x is 32, what y is going to be. So with algebraic, you have a formula. Numerical, you have numbers. And obviously, graphical means you have a graph of your numeric data or a graph of your algebraic equation that gives insight into the relationships between the variable quantities. Again, in general, if I give this graph, and this is seconds on the x-axis and inches on the y-axis, as time increased, distance increased. So, what type of graph is that? Well, maybe that's going to be half of a parabola. Maybe it's going to be exponential. You can look at data and gain some insights. And that data, you could make a graph. You could then find a line of best fit, which means you could make an equation. So that's really, which I'll show you. I'm actually going to do that before I do that. And, just thinking, what did we do with this in like an algebra 1 or 2 class? I gave you numerical data. So I gave you years. This is prison population in thousands total. And then I compared male and female. You could look at this and tell me, hey, males are more than females. Males is going up, females is going up. Total is going up. So that's general ideas about this data. But you could make a graph of that. You could plot on a coordinate graph and make a scatter plot and have this be year. You could do different ones. You could have female, male, total, 3 different colors. And you could see, is it linear? Is it positive correlation, negative correlation? So we do that this year, like fitting a curve to data. If I gave you this, and really what this is really showing us is that this is numerical data, 0, 3.8, 5, 4.4, 10, whatever, okay? What you did then was you made a graph of that numerical data. Well, then the next thing you could do is draw a line of best fit, and you could find an algebraic model for that data. So that's really where you want to see that the 3 things go together. I always show the graphing calculator. Something that my graphing calculator shows is if I press this, you can see, hopefully if it's there, maybe it's not working, but the equation would be your y equals. The table would be your numerical data. The graph is the picture that you have on the graph. So, those 3 things definitely go together. So, last thing that I want to go back to is, and this is really where some of this is going to be review. What should you be able to do so far in this class algebraically, which means you're showing me all your work. You can solve linear, x to the first. You can solve quadratic. If you can't, you're going to still work on it. But you should be able to solve quadratic. When do I expect you to be able to solve something higher than an x squared? So a higher power, if you can factor it, so I'm not doing anything but factoring, down to a linear or quadratic. And the type of factoring that we're talking about really is taking something out. So if factoring, we're using the zero product property where we set each of those things equal to 0. So only time I can do x cubed, x4, x5, etc. is if I can factor it down to a linear or a quadratic. The other thing that I should be able to do is solve an equation with a square root, because I should know to get rid of a square root, I square. But with that, you need to make sure you always check for extraneous solutions. So most of the homework that I give you is solving algebraically or solving graphically. So if I said solve this algebraically, first thing you would want to do, get it all on one side. So I'm going to obviously subtract those. Now what I can see is that I have an x to the third, but they all have an x. So I can take an x out. Now sometimes I can take a number with that, but there's no number that goes into 6, 11, and 10. So I take an x out. I have 6x squared minus 11x minus 10 equals 0. I set this equal to 0. I know I have an answer of 0. Now, how do you solve that? You might try to factor. A lot of people would say to me, I'm just going to use it's a quadratic. I can use quadratic formula, opposite of b, plus or minus b squared minus 4 times 6 times negative 10. all over 2 times 6. I'm thinking of the answer. And if I take 11 squared minus 4 times 6 times negative 10, I get 361, which is actually a perfect square. So I would have that over 12, which is 11 plus or minus 19 over 12, which means I would have to do 11, 11 plus 19, 30 divided by 12, 2.5. 11 minus 19, which is negative 8, divided by 12, which is negative 2/3. So I really, for that whole problem, I can't forget the 0, have 3 answers. So that's a quadratic that I can, a cube that I can take down to a quadratic. This one, I have a square root. I know that to get rid of a square root, I square. Whatever I do to one side, I do to the other side. But you have to remember that's a quantity. So you have to think of that as x plus 1 times x plus 1, which is x squared plus x plus another x plus 1. And that equals 7x plus 15. So then that's x squared plus 2x plus 1. And I have a quadratic. So if I have a quadratic, I know how to solve that. Bring it all on one side. Minus 7x minus 15. X squared minus 5x minus 14. Now, how do I solve that? Quadratic formula, factoring, your choice. I know that 7 and 2 subtract, so I get 7 and negative 2. Now I have to check back into the original problem. Well, 7 times 7 plus 15, square root of 64, is equal to 7 plus 1. But if I put negative 2 in, that's going to be the square root of 1 equals negative 1, which is wrong. So I would cross that off. That's my only answer. Now you think of this graphically, which I sort of want you to start thinking of. 7x plus 15 square rooted is like this. X plus 1 is like that. How many answers does that equation have? How many times does it cross? Once, not twice, which is why we get that extraneous. So I should be able to solve those, and just make sure with solving graphically using a, and this is more the calculator, but don't depend on your graphing calculator or Desmos. They can misrepresent information, so make sure you investigate. Like if you can't tell if it's a 0, you better zoom in and check to see if it's a 0. So they can misrepresent or they don't show hidden behavior. So that's really the first section. It's just sort of an introduction and a review over solving, the only one we hadn't done. And this sort of shows you with a graphing calculator hidden behavior. If you graph that, that's what you get. And, you know, where does it equal 0? You're thinking here, but here, you don't really know. So you better zoom in and really see what's happening. So you should be able to finish the assignment, and I will see you next week.